We're going to start today talking about exponential decay. So these are the exponential decay notes. So we're going to start just like we did before. We're going to graph these functions by creating a table of values. So we have y equals 1/2 to the x. So we're going to make a table of xy values, and I'm going to plug in -2, -1, 0, 1, and 2. So now we're going to take 1/2 to the -2 power. I'm going to do this up here at top so you can see exactly what's happening. So if we're taking 1/2 to the -2, this happens to both these things. So this is the same thing as 1 to the -2 and 2 to the -2. Now remember, when we have negative exponents, if we want to get rid of negative exponents, we move them across the fraction bar. So basically what happens is this comes up to the top and this drops down to the bottom. So we have 2 squared over 1 squared, which is going to turn out to be 4. So this is 4. Now I'm not going to do all of that work out on all of these, but that's the general idea of what's happening here. So if we have 1/2 to the -1, remember that -1 power happens to both. We flip them across the fraction bar, and so we're going to get 2. 1/2 to the 0 power, anything to the 0 power is just 1. And then we have 1/2 to the first, which is 1/2. And 1/2 squared. Again, that square happens to both these things, so 1 squared is 1, 2 squared is 4. So when we graph these, we have the point -2, 4. That's over here, sorry. We have the point -1, 2. 0, 1, 1, 1/2, and 2, 1/4. Oh, sorry. Okay, so what you can see is happening here is this is getting smaller and smaller. It's going to have an asymptote there at 0. And this is getting bigger in this direction. This should look really, really familiar because when we did last week, when we did y equals 2 to the x, this graph was going the opposite direction. Remember? Y equals 2 to the x, the graph looked like this. Okay. All right, so let's take a look at the next one. Y equals 1/3 to the x. We're going to do the same thing, set up our table of values. Okay. When we plug in -2, when we take 1/3 to the -2 power, remember that -2 happens to both those things. We flip them across the fraction bar, so this is going to turn out to be 9. When we take 1/3 to the -1, that -1 happens to both of them. We flip them across the fraction bar to get rid of the negative exponents. So this will be 3. 1/3 to the 0 power. Of course, anything to the 0 power is just 1. 1/3 to the first power is 1/3. And 1/3 squared, you square the top and bottom and you get 1/9. So for this, we have -2, 9, which I can't fit on my graph. 1, 3. 0, 1, 1, 1/3, and 2, 1/9. So this has a very similar looking graph. It's just a little steeper here to the left, so it's coming down a little bit faster than our 1/2 did. All right, you can probably guess what's going to happen with 1/4 to the x. So we're going to set up a table of values. 1/4 to the -2 power, everything's going to flip across the fraction bar. We're going to get 16. 1/4 to the -1 will be 4. 1/4 to the 0 power is 1. Sorry about that. 1/4 to the first is 1/4, and 1/4 squared is 1/16. So -216, I can't fit that. Here's -1/4, 0, 1, 1, 1/4, and 2, 1/16, and very similar graph. Again, it's just steeper than before. Oh, we forgot the domain and range in all these. Sorry. Clearly, you can see the domain for all of these is all real numbers. And the range in all of these, they all have the same asymptote, the y equals 0, so all of the ranges is y is greater than 0. So we call these exponential decay functions. This equation right here, y equals ax times b to the x, this should look super familiar because it's the same Same equation for exponential growth. The reason that we're going to know it's exponential decay is because our base, this b, is between 0 and 1. Okay, that's what causes it to be decay. It's because we're taking, if it's a half, we're taking something, and each time we do it, we take half of it, or a third of it, or a fourth of it. Okay, so we have exponential decay when the base b is between 0 and 1. Okay, this a out front, that could be a negative number. It could be something else that's going to reflect it or stretch it or compress it. Okay, if the b is greater than 1, this would be exponential growth. Some key features of exponential decay. The domain is all real numbers. The range is greater than 0. And notice all of them had the same intercept, 0, 1. They all had the same asymptote, y equals 0. Now that's before transformations. And the end behavior. As x approaches infinity, so this is right-hand end behavior. So when we went to the right, y was approaching 0. And as we approach negative infinity, this is left. Y is approaching infinity. Okay. So we learned last week that exponential growth functions have this general shape. Exponential decay functions have this general shape. Okay, those going down. And the difference is the base B that we have. So in the next video, we'll investigate how to deal with our transformations on these things.